Hello everyone, welcome back again. So you know that this video series on computer system architecture, that is second paper of BSc first semester CBCS students. So we are discussing about combinational circuit. So in the last video we have discussed about multiplexer and demultiplexer. So multiplexer and demultiplexer are two important combinational circuit, and today we will learn or discuss another very important combinational circuit, that is encoder, and after that we will learn decoder. So what is encoder? This encoder is also a combinational circuit. Encoder is also a combinational circuit that converts binary information in the form of a 2 to the power n input lines into n output lines. So in this combinational circuit, that is encoder, it will convert binary information in the form of a 2 to the power n input lines into a n output lines. 2 to the power n input line and n output lines, which represents n bit code for the input. So for a simple encoder, it is assumed that only one input line is active at a time. So this is a block diagram of an encoder. You can see here n input lines, only one is active, that is high at a time, and here is m bit output code. So if the input lines is 2 to the power n, the output line will be n, small n. If 2 to the power n, small n, 2 to the power small n is input line, output line will be n line. So this is the block diagram of a encoder. Again, you can see the application where encoders are used. This is very important, why we need this encoder combinational circuit. So you can see here, it encodes one of the active input such as decimal or octal digit to coded output such as binary or BCD. So this encoder can be used as a converter. From octal to binary or BCD code. So encoders can also be used to encode various symbols and alphabetic characters. So they can also be used to encode various symbols and alphabetic characters in the shortest form. So the process of converting from familiar symbols or numbers to a coded format is called encoding. So encoding is the process by which we can convert any kind of symbols or numbers into a coded format. So in an encoder, the number of output is always less than the number of inputs. This is important point, that number of output is always less than the number of inputs. So this is the block diagram of a encoder. Then we have an example of encoder, that is octal to binary encoder. So in your exam, you are asked to discuss about or explain about octal to binary encoder. That explain about octal to binary encoder, write its function table and logic diagram. So you have already known that encoder is a combinational circuit which converts 2 to the power n input lines into n coded output lines. So for example, we will see this octal to binary converter or binary encoder. So this will encode octal number to octal to binary encoder, that is 8 line to 3 line, performs the opposite function. An octal to binary encoder performs the opposite function of a decoder. So we have already discussed about decoder. Decoder does what? Decoder converts binary to octal, that is 3 line to 8 line. But in case of encoder, 8 line is converted to 3 line. So number of output line is less than input line. That means what? Encoder performs the reverse operation of a decoder. Encoder always performs the reverse operation of a decoder. So the logic diagram and truth table of an octal to binary encoder is shown in the following figure. So it is implemented with 4 OR gate, and the circuit is designed to so that when D0 is high, when this D0 is high, that means when D0 is 1, the binary code 000 is generated, and D1 is high when binary code 001 is generated, and so on. So if you see the truth table, actually you need to see the truth table first. After that you can draw this logic diagram. So if you see this truth table, you can see here. So when this output is 000, that means D0 input is activated at that time. So that is what we have written here, that the circuit is designed so that D0 is high when the binary code 00 is generated. So when 001 is generated, then D1 is high. So when 010 is generated, then D2 is high, and similarly we can get the other high inputs. Okay, so all these are actually theory parts, so you have to remember this theory for your exam. So how you can remember? You can see here this diagonal elements are 1, diagonal elements are 1 and others are 0. So first write here 1, then second one, then third number is 1, then fourth one, fifth one, and similarly you can remember this easily. So here 0 0 0 0 0 1 0 1 0, that means this column 1 0, first one is 0, then 1 0 1 0 1 0 1, after that 2 0 2 1 2 0 2 1, this one 4 0 4 1. So this is how you can remember this truth table. So if you can remember this truth table, you can draw the logic diagram easily. So from the truth table we can draw this logic diagram easily. So this is the logic diagram of octal to binary encoder. Why it is called octal to binary encoder? Because number of input lines are 8, but the output line is 3, 1 2 3. Why it is y0 is equal to d1 plus d3 plus d5 plus d7? Why? You can see here. When we get y0, when we get y0 1, আমি y0 to কেতিয়া 1 পাম যেতিয়া আমি কেতিয়া পাইছো যেতিয়া d1 to d1 যেতিয়া 1 আছে তেতিয়া আৰু কেতিয়া পাম যেতিয়া এটো 1 কেতিয়া পাম যেতিয়া d3 to 1 আছে আকৌ এটো 1 কেতিয়া পাম যেতিয়া y5 ত 1 আছে আকৌ এটো 1 কেতিয়া পাম যেতিয়া d7 ত 1 আছে so this y0 is equal to what this d7 plus d5 plus d3 plus d1 যত 1 আছে এই গেটাৰ আমি প্লাস কৰি লব লাগিব যত 1 0 ৰ কাৰণে আমি 1 পাইছো এটো 1 আমি এইফালে কেতিয়া 1 থাকতে পাইছো d1 1 থাকতে ইয়াতে আমি y1 y0 ত আমি 1 পাইছো আকৌ এটো 1 কেতিয়া পাইছো d3 to 1 থাকতে আমি এইফালে 1 পাইছো সো জি গেটাৰ কাৰণে আমি 1 পাইছো এটা আমি প্লাস কৰি দিব লাগিব আকৌ y1 টো কেতিয়া আমি পাইছো y1 টো কেতিয়া 1 পাইছো যেতিয়া d2 1 আছে আকৌ d3 1 আছে আকৌ d6 1 আছে আৰু d7 1 আছে so y1 to কি হৈছে d3 plus d4 plus d6 plus d7 you can see here y1 is equal to d2 plus d3 plus d6 plus d7 so এনেকে c কেইটাৰ কাৰণে y1 ত 1 থাকতে জি কেইটাত 1 আছে এটা আমি এনেকে প্লাস কৰি দিব লাগিব আৰু হেই মতে আমি লজিক ডায়াগ্ৰামটো আঁকি লৈছো ঠিক আছে so this is how encoder works so what you need to do you have to remember the truth table first so after that truth table you will get this y1 sorry y0 y1 and y2 as a characteristics function and after this characteristics function you can draw the logic diagram okay so thank you